Okay, now this is another question which is from paper one, uh, June 2016, question number 7. This is identities. Remember the two identities that we use? I'll just write them down over here. The first identity that we use is tan theta is equal to sine theta over cos theta. Since the identities, so it's 3 equal to signs we have over here, 3 dashes. This is sine squared theta plus cos squared theta is equal to 1. That can be written as, that depends on us. If we want to make sine squared theta the subject, so this is going to be 1 minus cos squared theta. If we want to make cos square theta the subject, so we have cos square theta as the subject, and we shift the other 1 minus sine squared theta. So we can use any one of these. So these two, this one and this one, is derived from this one. So this is basically the same property. We're just rearranging it and writing it in a different way. So let's get ahead with part one. Part one says you have to prove that the left hand side, which is this whole side starting from here till here, is equal to the right hand side, which is from here till here. So it's all, you can prove anything. You can prove the left hand side is equal to the right hand side, or the right hand side is equal to the left hand side. That's your choice. I always go on with the, or I always select the side which is harder or which is more longer and more complicated. Then you get it easier. It's easy to solve it and get the answer. If this is already in the simplest form, then just to expand this and bring this into this form, that would be harder. But this is already in a complicated form, so that, and bringing this into simplified form, into this, just this, that seems to be easy. So that's why I always select the harder side and solve it and make it to the easier one. So I am selecting the left hand side, and I will go ahead with this, the left hand side, which is 1 plus cos theta over 1 minus cos theta minus 1 minus cos theta over 1 plus cos theta. So first we take common denominator, we take the LCM, we have 1 minus cos theta bracket, we have 1 plus cos theta. So now this, we already have 1 minus cos theta over here. So in the numerator, we have 1 plus cos theta, and that will be multiplied by this 1 plus cos theta. So that would be 1 plus cos theta squared minus, same goes over here, 1 minus cos theta whole thing squared. Now this is a minus b, a plus b. So in the denominator, what I get is a squared minus b squared. So that would be 1 minus cos square theta. In the numerator, now I have this, I will expand this by a plus b whole squared. I'll be expanding this by a minus b whole thing squared. So if I expand this, the first bracket, that would be 1 plus 2 cos theta plus cos squared theta. Minus sign is outside. This is 1, so that's 1. This is negative. Minus sign is outside, so that's going to be make it plus 2 cos theta plus, but the minus sign is outside, so that's going to make it negative. Negative, and I get cos squared theta. So now what do I have? I have 1 over here, that's a plus 1. That's a negative 1, cancels out. I have 2 cos theta right over here. I have cos square theta here. I have minus cos square theta, cancels out. I have 2 cos theta right over here. I have 2 cos theta right over here. That gives me 4 cos theta over, if I remember this, 1 minus cos square theta, like I said right over here, 1 minus cos, I can use this and this. So I need, well, I'm replacing 1 minus cos square theta, and that is equal to sine square theta. So I'll replace my denominator by sine squared theta. How many sines do I have in the denominator? 2, because there's sine square theta. So I can rewrite this as 4 cos theta over sine theta and another sine theta. Sine theta and sine theta is sine square theta. Because if I look at the question, I need 4 over sine theta into tan theta. Now tan theta is right over here, the first identity that we have, which is right, the first identity we have, tan theta is equal to sine theta over cos theta. Tan theta over here is in the denominator. So if tan theta is equal to sine theta over cos theta, let me just write over here, tan theta is equal to sine theta over cos theta. So what is 1 over tan theta then? 1 over tan theta would be the reciprocal of this, because I'm taking the reciprocal of this side, so that's 1 over tan theta. So I need to take the reciprocal of the other side, which is this, which is going to give me cos theta over sine theta, which is what I have over here. Cos in the numerator, sine in the denominator, right over here, cos theta and sine theta. So this cos theta over sine theta will be replaced by 1 over tan. So I get this as 4 over sine theta. I already have one sine theta left. The other sine theta is used with cos theta over sine theta to get 1 over tan theta, which is tan theta. So basically what I've done is, if I break my numerator up, and I can write it like this, 4 cos theta over sine squared theta. I'm just doing it again to make you understand. 4 cos theta over, I got this as sine theta, and there was another 1 over sine theta over here. So that gave me 4 over cos over sine theta was 1 over tan theta, and this is already 1 over sine theta. So that just gives me 4 over sine theta into tan theta. So that's part 1 done. I have shown that the left hand side is equal to the right hand side as given in the question. Moving on to part 2, hints of for this is important. Whenever you start, please look at this, what the range is given. The range is given from 0 to 360. So that means the calculator has to be in degree mode. And we have sine theta multiplied by this whole thing. And this whole thing is what we had in part 1, right over here. So this whole expression is equal to this expression. So what I'm doing is, I'm just doing sine theta multiplied by this expression is equal to 3. What I have proved. So part 2, sine theta is equal to, is multiplied by, sine theta multiplied by the whole expression, and the whole expression is basically 4 over sine theta tan theta, that's what we proved, is equal to 3. This is what the question is asking us to do. The question is asking us to solve this equation, which is between this 0 to 360 degrees. So this sine and this sine cancels out. I'm left with 4 over tan theta is equal to 3. Then I just 4 cross multiply the 3 and the 10, switch the places. So that's what I've done. So the tan goes over here, tan theta. So tan theta is equal to 4 over 3. Now if I just quickly use the calculator. So I have, has to be in degree mode. So shift number 2, number 1, I'm selecting degree. Now my calculator is in the degree mode. So I have tan inverse of, so theta is equal to Sorry, let me just find this first. Let me just find this first and then we'll get ahead with on with the question. So tan inverse of 4 over 3. Subtraction 4 over 3. That should give us the answer. Basic angle, which is 53.13. Fine, 53.13. 53.13. So now this is 53.13. We get theta as 53.13 from what we have done is we have taken theta is equal to tan inverse of 4 over 3, which is theta is equal to 53.13 as the basic angle. Now remember, this tan whole equation is basically the positive equation. So we have tan as positive over here. So what do we do when we have tan positive? We have tan positive in the first quadrant, which is just theta, and add sugar to coffee. So we have in the third and the third. So this is the first and the third quadrant. What happens in the third quadrant is 180 plus theta. So just to give you a recap right over here, we have A, all positive, only sine, only tan, only cos. This is the first quadrant, this is the second, this is the third, this is the fourth. In the first quadrant is only angle theta, and the second one is 180 minus theta. The third one is 180 plus theta. The fourth one is 360 minus theta. So we have the third one, which is 180 minus theta, 180 plus theta, the third one. So that is going to give us 180 plus 53 point this. That would give you 233.1. So that's our answer. So we have the two answers, the two values. When tan is positive, we write the final answers as 53.1 and 233.1. You need to remember it's given in the start of the paper. You haven't read the paper yet, of course. It's given in the instructions. Whenever, as in the case of angles, it has to be correct to one decimal place. So correct to one decimal place is 53.1 and 233.1. That's done. June 2016, question number 7.